Welcome everybody. We're going to continue the study of rigid body kinetics by looking at the conceptual problem C56 from your book. In this problem, we have a rear-wheel drive car that is experiencing forward acceleration on a horizontal roadway, and we're asked to find the friction forces between the tires and the roadway choosing amongst these four options that we have below. So in order to tackle this problem, we will first break up our car into subsystems. Specifically, we're going to look at what happens to each tire as we're asked to find forces. So our free body diagram strategy is to break up the system. So let's first consider the rear tire. So the forces and moments experienced by the rear tire, we can first, we're going to ignore the forces in the y direction and assume all motion is occurring in the horizontal direction. So we will first consider in which direction is the tire rotating and which is the cause of that rotation. Well, if we have a rear wheel drive, then this tire will be experiencing a torque that is coming from the engine. So this torque is actually the cause of the rotation of the tire. And if we're going to be moving to the left, then this torque is going to be in the positive direction. So we have an accelerating car means that both the angular velocity and angular acceleration are in the same direction, and the torque that causes them is positive. Now let's consider which other forces we have. Well, we'll have a force that is imposed by the axle on the tire, and the friction force, which be due to the motion between the tire and the roadway. So in this case, we'll need to be careful in considering what direction is the friction. And I will allow you to pause the video for a second to consider your options. So considering that the wheel is rotating by an imposed external torque from the engine in the counterclockwise direction, the positive direction, then we know that the friction would be opposing that motion. And hence, we can assume that is to the left. So if we write our equations of motion now for this rear tire, we would have that in the x direction we have the friction force plus the force of the axle, and this will be equals to the mass of the tire times acceleration of 0.0. We assume the tire is homogeneous, so the center of gravity would be at the center. Now this tire will be having a radius of r, and hence the torques acting on the tire, if we take moments about 0.0, which is our center of gravity, then we will have that the torque from the friction force is negative, and we have the positive torque from the engine of the car, and this should be equals to the mass moment of inertia of the wheel times the angular acceleration. Since we know that the right-hand side of this equation needs to be positive, then we know that the torque from the engine needs to be greater than the torque imposed by the friction force, much greater, to be able to move in the forwards direction, which in this case is left. Having established the direction of the friction force for the rear tire, now we turn our attention to the front tire. Okay, so in this case, we have our free body diagram here. We can assume once more, well, this is not an assumption, but we know that the direction of rotation of the tires is going to be the same in both the front and the back. And now in this case, we have to be a little bit more careful because since the vehicle is rear-wheel drive, then for the back wheel, we're not going to have an imposed torque. So which forces are acting on the x direction on the front tire? Well, we have again the force from the axle acting on the wheel. And now we need to consider carefully what is the direction of the friction force. So intuitively, one would assume that because the contact point is coming in this direction onto the ground, then friction should be in the negative, in the direction equals to the one for the rear wheel. But maybe this is not going to be the case. So anyways, let's move forwards with this assumption. And let's see if our equations are going to tell us whether we are right or wrong with this assumption. Okay, so in this case, we have for the summation of forces in the x direction, we have the force from the axle. And here, actually, we say that this is to the left, and let's assume left is positive. And now we have also the force of friction in the same direction, and this is going to be equals to the mass times acceleration of the center of gravity of the tire. To calculate the moments, again, we can use, for instance, point O as in the rear tire, and then this will lead us to have the friction force of the front wheel causing a negative moment, and then we will have on the right hand side the moment of inertia times alpha. Now, of course, we know that alpha is positive, hence friction should actually be causing a positive moment. So then, in reality, friction force in the case of the front wheel is going to be pointing in the direction opposing the motion from the car. Now we can see this even clearer if we recall the fact that the car is a rigid body, and hence the acceleration of the car, it's equals to the acceleration of points O, the center of each of those tires. And this acceleration is actually to the left. So in here, I am assuming that left is positive, all right? So what does that tell us? Well, it also tells us that this is positive. So of course, the force of the axle needs to be much larger than the friction force, which is going to be in the negative direction in this case. With this, we conclude the solution of conceptual problem 5C6. I hope you have enjoyed it. And if you have any questions, please send me an email. I'll be very happy to answer them.